All right, so when you multiply a matrix by its inverse, you get the identity matrix. So this happens for numbers as well. If I multiply 5, the inverse of 5 would be 1 over 5. And when I multiply those together, I get 1. And 1 is the identity of multiplication, normal multiplication. Okay, so the identity for matrices we are about to find out, because this is matrix A, and I've already given you one that is A inverse. So that little -1 exponent is what stands for inverse in all of math. And this guy's a 2 by 2, and this guy's a 2 by 2. They have to be the same dimensions. They have to be squared. Okay, so we're going to multiply these real quick. So we're going to focus on rows on the first one and columns on the second. So we're going to do, ooh, that's fun. We're going to do 3 times 2 plus -1 times 5. And then we're going to do -5 times 2 plus 2 times 5. Over here, we're going to use 3 times 1 plus -1 times 3. And then down here, we're going to use -5 times 1 plus 2 times 3. So when we go through and do a little bit of arithmetic here, we get 6 plus a -5, which gives us 1. We get 3 plus a -3, which gives us 0. -10 plus 10 also gives us 0. And -5 plus 6, which gives us 1. So this is the identity matrix. So something to take note of is that not all matrices will have an inverse. And how you tell that is if the determinant is 0, then it doesn't have an inverse. So if you check an inverse for its determinant and make sure that it's not 0 first, if it is 0, then you just tell me, you can't fool me, Miss Holly. You know, undefined does not have an inverse. Okay? So there are 2 ways to solve for inverses. One is absolutely easier than the other, but this is one of those rare situations where I may force you to solve it in the complicated way. Okay? So it might be one of those situations where even though you can solve it in an easier way, I might say, I need you to solve it using this method. Okay? And then for the most parts, we'll use the shortcut. Okay, so let's figure this. So we know if this guy right here is matrix A, we know I'm going to have to multiply it by some other matrix. So we will just name those elements X, Y, W, Z. Just name them something arbitrary. We know that when we multiply them, they should equal the identity matrix 1, 0, 0, 1. Sounds like you're talking in binary. Okay, so what we can do is we can actually multiply these 2 together and see what we get, and we end up with little equations that we can then solve. Okay, so we're going to focus on the rows here and the columns here, and we're just going to multiply these guys together to get what A times A inverse is. So 5 times X plus 7 times W will be my first element. 2X plus 3W will be my second row, first column. If I go over into my first row and my second column, I'm going to get 5Y plus 7Z. And in my second row, second column, I should get 2Y plus 3Z. And we know that this should be equal to 1, 0, 0, 1. Now what's cool is we can actually set up an equation because I know that this first element should match this guy. So I'm going to have 5x plus 7w, and I know it's going to equal 1. I've got 2x plus 3w, and I know that that equals 0. I have 5y plus 7z, which I know equals 0, and I have 2y plus 3z, which I know equals 1. And then what we end up having here is a beautiful little system of equation. So this is a beautiful little opportunity to practice systems of equations because you probably haven't seen them in a bit. Okay, if you love systems of equations, which I'm sure some of you totally do, okay, this is awesome. And if you don't, it's a good chance to practice it with one that honestly isn't that tough. So it's kind of nice. So remember, with systems of equations, these two have the same variables, x and w. These guys have y and z. So if we're going to use elimination, you can use substitution if you want to, but I'm going to use elimination. Again, you should be able to do this without a calculator, just FYI. This would be considered no calculator piece. So I need to make one of my first numbers, one of my coefficients, the same exact number, but opposite signs. So I'm going to go with my 5 and 2. So I'm going to multiply this top one by a -2, and I'm going to multiply this bottom one by a +5. So if I distribute that -2 to everything, I'm going to have -10x minus 14w equals -2. And then on the bottom, I'm going to have 10x plus 15w equals 0. And then I can add those guys together. This guy will cross off, and I'm going to get w equals -2. So I already found one of my elements. Okay? So let's just set that up over here, which means we're going to have to look at where w fell. So this was... So w's in this bottom corner here, so that guy right there is a -2. All right. And we're going to go back, and we're going to figure out what x is. So I know that 2x plus 3 times w, which is -2, equals 0, which makes my life pretty easy. So 2x minus 6 equals 0. I can solve that in 2 steps. Add the 6 over, divide by the 2, and x should be 3. Okay. That goes right up top here. Got my x value in that first row, first column. So I will put that 3 right there. And then we're going to do the same thing over here. And what's nice is, because you're using the same elements, you're going to end up being able to just multiply this by the same values as the last one. But remember that what they're equal to, the constants, are going to be different because they've swapped. So I've got -10y plus, or negative, minus 14z, however you prefer to write that, equals 0. And I've got 10y plus 15z equals 5. Do not forget to multiply those guys. That's definitely probably one of the biggest errors that I see people making, including myself when I first went through this because I was rushing. Okay, so these guys knock out, and again, we just get z equals 5. So 5 is going right here, and then I'm substituting it back in. So we get that 5y plus 7 times 5 equals 0. So 5y plus 35 equals 0. And then if we subtract 35 from both sides and we divide by 5, you should get that y equals -7. So my last value up here is -7. This guy right here is my A inverse. Now, keep in mind, right, this is a big process. This takes a decent amount of work. So keep in mind what we're always talking about with testing skills and study skills. I would not ask you to do 5 of these, right? This is one where you'd probably see one of them on a test or a quiz, okay? There is a way to check also. You should be able to take your original matrix A and multiply it by the matrix that you've got, which should be A inverse, and you should end up getting your inverse matrix, okay? So if you'd like to pause the video and try that, you absolutely can. I'm going to go through the shortcut next, so if you want to pause and you want to try number 1 and 2 on page 5, you can absolutely do that so that you are getting a chance to practice this. You might want to bust out some scrap paper because this does take a little bit of space, okay? And then if you want to come back and unpause, you can then listen to the really cool, awesome, weird, patterny shortcut. And if you look at these two here that are inverses of each other, you might start to see a little bit of what the pattern is, but there's some little finesse to it that you need to be careful with. Okay? So, two things you're going to do. First thing you have to do, if you want to do the shortcut, is to find the determinant. Okay? And then we're going to have to swap the matrix around, swap the elements, and I'll show you how to do that in a second, and you're going to have to multiply it. So I'm going to show you how all this works, okay? So the inverse is going to be 1 over the determinant of A, okay? And then you're going to multiply it by a weird reversal of the matrix. So you're going to swap A and D. So D will go here and A will go here. And then for B and C, they're going to stay in the same place, but they're going to change signs. So if they're negative, they become positive, positive, they become negative. Okay? So let's try one of these in action. Maybe try both of them in action. Okay? So first thing we have to do is find our determinant. So 3 times 2 is 6. 5 times -1 is 5, and 6 minus 5 is 1. So in this case, the determinant is just 1, which is awesome. It makes our life very, very easy. So 1 over our determinant, 1, times, now I have to reorganize this. So 2 and 3 swap places, and the -5 and -1 swap signs. Okay? And then we multiply through. So in this case, we're just done, because 1 times anything, it being that multiplicative inverse, you're done, and that's all it is. So if you have a determinant of 1, it definitely makes things way, way easier. Okay? But let's look at example 2 here, or matrix B, because this one does not have a determinant of 1, so that you can see both examples. So in this case, -2 times 4 gives you -8, and 5 times -2 gives you -10. So -8 minus a -10, remembering that subtracting a negative gives you a positive, gives you a positive 2. So I'm multiplying by 1 over my determinant of 2 times my matrix rearranged. So 4 and -2 get swapped. 5 and -2 get their signs flipped. And then we multiply through here. So 1/2 of 4 is 2. 1/2 of 2 is 1. 1/2 of -5 is -5 halves. And 1/2 of -2 is -1. You need to be very comfortable with fractions here. You're going to get fractions. Okay, fractions are going to happen a lot here, okay? So you can use this shortcut. I want you to be very comfortable with this shortcut, because we are going to find inverses for other things that we do, okay? So that is going to be numbers 3 through 8 on pages 5 and 6, okay? And keep in mind, when you solve your determinant, if you get a 0 here, you just write no inverse. You can't fool me, Miss Holly. What you talking about, Willis? All acceptable answers. And then you just move on with life, right? Okay? For 3x3 matrices, we are going to bust out our calculator for the first time in this packet, okay? So I'm going to pause on that here and give you a separate video for that.